Hello, ladies and gentlemen. Today we're going to look at the three basic trigonometric ratios, the sine, cosine, and the tangent. All right, these are all ratios of side lengths of a right triangle. All right, let's say we have a right triangle, and let's call that right triangle A, B, C, with C being the right angle. Opposite each angle is a side. All right, opposite angle A, I'm going to put a little a to represent the length of segment BC. All right, opposite angle B, I'm going to put little b to represent the length of segment AC. And opposite angle C, I'm going to put a little c to represent the hypotenuse length, segment AB. Okay, now please be aware that A, B, and C can change, all right, depending on where you put your variables, all right. But in either way, all right, the sine of an angle, and that is abbreviated SIN, is defined as, and I'm going to put the sine of some angle theta. We use Greek letters theta, all right. The sine of angle theta is the opposite leg length. All right, let me write that down. Opposite leg length, all right, divided by the hypotenuse leg length. Okay, all right, this is read the cosine, and the abbreviation for cosine is COS, and we don't use, if you notice, we don't use capital letters except when we name it like this with the full word, and you don't need to do that very often, so don't worry about it. All right, so the cosine of an angle theta, and by the way, theta usually refers to one of the acute angles, all right, and that's what it tells you right here, okay, all right, is equal to the adjacent leg length divided by the hypotenuse length. That's a U, hypotenuse length. Okay. This one is the tangent, and that's abbreviated TAN, and the tangent of theta is equal to the opposite leg length divided by the adjacent leg length. Okay, all right. Now, example number 1 says, find the sine of angle A, the cosine of angle B, A, the tangent of angle A, the sine of angle B, the cosine of angle B, and the tangent of angle B. Express each ratio as a fraction and as a decimal rounded to the nearest hundredth. Okay, well, let's start with angle A over here. All right, and we're going to do, it wanted the sine first, so we'll do the sine of angle A. Well, the sine is equal to the opposite leg length. Well, opposite angle A is 5. So 5, all right, and we divide that by the hypotenuse length. Well, that's the 13. So 5/13 is the sine, okay? All right, and let's take 5 and divide that by, whoops, not 12, by 13 to get that decimal approximation to the nearest hundredth, which is 2 decimal places. So that sine would be approximately 0.38, okay? Actually, let's round this to the nearest thousandth. That's what I want. I want to change that to the nearest thousandth. All right, which is 3 decimal places. So 0.385. Let's do that. Okay, so that is approximately 0.385. All right, next, let's find the cosine of angle A. The cosine of angle A, all right, remember cosine is the adjacent leg. Well, here's angle A, and the adjacent leg is the one that forms that angle, the leg, by the way, not with the hypotenuse. So that's 12. Adjacent leg length 12 divided by the hypotenuse length. Well, the hypotenuse is still 13, all right? So 12/13. So 12 divided by 13, and we're going to round that to the nearest thousandth, okay, which is 0.923. All right, so set that aside, and that is approximately 0.923. Here's your exact answer. There's the decimal approximation to the nearest thousandth, okay? Now we're going to find the tangent of angle A. Well, the tangent is the opposite leg length. Well, here's angle A. Opposite that is the 5. So that would be 5. Opposite leg length 5 divided by the adjacent leg length 12. Okay, so 5/12. and that's 5 divided by 12, which would be approximately 0.417, okay? So that is approximately 0.417. All right, so there we have found the sine, the cosine, and the tangent for angle A. Now let's do the same thing for the other acute angle, angle B. So let's go find the sine of angle B. All right, now please recall the sine is the opposite leg length. Well, from angle B, the opposite leg length is 12 divided by the hypotenuse length, which is still that 13. So 12/13 is the sine of angle B. Notice that's also the cosine of angle A. And if you've already put in 12/13 in your calculator, there's no need to do that again. It's going to still be 0.923, isn't it? Okay. All right. Next, let's find the cosine of angle B. Well, the cosine is the adjacent leg length. All right. And if you're talking about angle B, the leg that forms that angle with the hypotenuse is 5. That's the adjacent. 5 divided by the hypotenuse leg length, which is still 13. Now, you did notice that 5/13 is the sine of angle A, and you've already approximated that, so that's 0.385. All right, and lastly, we need to find the tangent of angle B. All right, so the tangent of angle B, and notice that the tangent is defined as the opposite leg length, so B opposite that is 12, and the adjacent leg length is 5. All right, and that can be simplified as to 2.4. And you don't need to round that because that terminated. If you did 12 divided by 5, it would terminate before you even got to the thousands. So you can just leave it like that. No need to put 0.400. Not necessary. Turn the page. All right. Example number 2 says, find the sine, cosine, find the sine of angle S, the cosine of angle S, the tangent of angle S, the sine of angle E, the cosine of angle E, and tangent of angle E. Express each ratio as a fraction and as a decimal rounded to the nearest, let's see, do we want to do hundreds or thousands? Let's do thousands, okay? All right, so we're going to change that to thousandths. All right. And we'll start with angle S. Okay, so the sine of angle S is equal to, remember, sine is opposite leg length, 3, divided by the hypotenuse leg length, that's opposite the right angle, which is the segment SE, or 5, so 3/5. All right, that's exactly equal to 0.6, so there's no need to round anything there, okay? All right, let's go find the cosine of angle S next, okay? Angle S is right here. The cosine is the adjacent leg, the leg that forms the angle with the hypotenuse, 4, divided by the hypotenuse, which is still 5. Okay, and that's exactly equal to 0.8. No need to do thousandths there. All right, and then we're going to do the tangent of angle S. The tangent is defined as the opposite leg length divided by the adjacent. So the opposite is 3, the adjacent is 4. Okay, and that's equal to 0.75, and there's no need rounding that either. Now, if you're having trouble remembering how these definitions, there's a little method that you can use. It's called the SOHCAHTOA, SOHCAHTOA. All right, S stands for the sine, and it's going to be the opposite divided by the hypotenuse. All right. C stands for the cosine, and it is the adjacent divided by the hypotenuse. All right. T stands for the tangent. It is the opposite divided by the adjacent. And you can remember that as SOHCAHTOA. All right, and that's one way that people remember it. If you need to use that, please feel free to do so. Okay, now let's go find the sine, cosine, and tangent of angle E. So the sine of angle E is equal to, so now we're over here. Remember, sine is opposite. Opposite is 4 divided by the hypotenuse, 5. Well, we already know that's the same decimal as this. All right, so that's 0.8. The cosine of angle E is the adjacent leg. That's this leg right here, 3 divided by 5. And we know that's 0.6 as well. And the tangent of angle E is equal to, tangent is the opposite 4 divided by, opposite leg divided by the adjacent, 4/3. Well, that's 1.3 repeating, and that will need to be rounded 1 point, and we're going to go thousandths, that's tenths, hundredths, and that would be thousandths right there, 1.333. All right. Now, you can use your calculator to evaluate expressions involving trigonometric ratios, all right? Find each value using a calculator. Now, I will tell you this. Your calculator, it can be in two different modes, radians and degrees. And anytime you see a degree symbol, you need to change the calculator mode to degrees. Let me show you how to do that. Okay, all right. If you take your calculator, all right, and press the mode button, and then go down once, twice. As you can see, my calculator was in radian mode. Anytime you clear the RAM, it defaults back to radian mode. So go down twice, and then go over to the word degree, and press enter. And if you don't do this and your angles are in degrees, everything you do will be wrong. Okay, now, example 3, part A, says to find the value of each using a calculator. And it should say round to the nearest whatever. All right, we're going to round to thousandths. Okay, that's what we're going to do. We're going to stay consistent, and we're going to round to the nearest thousandths. Okay, so now we're going to do, right here, by the way, these are the buttons that you use for your basic trig function, sine, cosine, and tangent. Once we're in degree mode, we can type in the cosine of 41 degrees. Now, we'll teach you about radians later, so right now just be sure you're in degree mode. Okay, so the cosine of 41 degrees is 0.75. Is that going to be a 4? Nope, because the next digit after that 4 is one of your 5 highest, so it's going to go to a 5. Okay, next let's type in the sine of 78 degrees. All right, that would be 0.97. Is that next number going to stay at 8, or is it going to go to a 9? Well, you look to the right. Okay, that right is one of your 5 highest digits. Okay, or excuse me, one of your 5 lowest digits, so you leave that as 0.978. All right, now trigonometry is very useful. Okay, you can use trigonometry to find lengths of triangles and angles of triangles, and we're going to do some of that, and we're going to start by finding some missing leg lengths or side lengths that could be the hypotenuse. In any event, when you're doing this sine, cosine, and tangent at this point, you need excuse me, you're going to need to use your calculator, okay? All right, and we're going to find x first. All right, now, if I want to find x, all right, here's x. It's this leg. Now, I could use, I got the hypotenuse. And by the way, if you think about hypotenuse, that works only with sine and cosine. And I will tell you that you could do sine or cosine for this equation, and it really wouldn't matter, okay? All right. I don't know, the arrow's pointing to the 21 degrees, that angle, so I'm going to use that one first, if that's all right with you. So if I'm using this angle, let's call it angle A for a moment. And x is opposite. So opposite I'm looking for, I know the hypotenuse. Well, which trig function has opposite and hypotenuse? That's the sine. So I would do the sine of 21 degrees is equal to the opposite leg length, x, divided by the hypotenuse, 9. What I would then do is make a proportion out of it, and then I would ask, what does x get multiplied by? Well, that's 1, and 1 times x is x, and that would be equal to the sine of 21 times 9, or 9 times the sine of 21 degrees. I prefer to write the whole number part first, because then I won't get mixed up and think of that as the sine of 219 degrees. And I recommend that you do that as well. And that is your exact value. And that's the equation that they want us to put right here. X is equal to 9 times the sine of 21 degrees. Or you could put the sine of 21 degrees is equal to x divided by 9. It's okay either way you want to do it. They're both valid equations. One's just been transformed a little bit. Okay, so now I'm going to type in, all right, I'm going to type in over here 9 times the sine of 21 degrees, okay? And that tells me that x, and when it says equals, I'm going to put that exact. It's 9 times the sine of 21 degrees, and then I'm going to approximate it because it didn't tell me to, but you should be doing that anyway. To the nearest thousandth, that would be 3.22. Would that 5 stay a 5 or go to a 6? We'll look to the right of it. 3 is one of your smaller digits, so it's going to stay a 5. Okay, all right. Let's move over to part B. Now, you have to decide which acute angle you want to work with. It really doesn't matter. All right, I read from left to right, so I saw this 37-degree angle first, so I'm going to use it, okay? If I want to use the 37-degree angle, I could say, all right, I'm looking for the adjacent leg because this is the leg that forms the angle. And I know the hypotenuse. Well, which trig function has adjacent and hypotenuse? Adjacent and hypotenuse is cosine. That's how you have to figure this out. So the cosine of that acute angle, 37 degrees, is equal to, cosine is the adjacent leg, x, divided by the hypotenuse. Now that equation could go here, or you can do the next one. It really doesn't matter to me. I'm going to do the next one because I'm going to make a proportion out of this. Since that right side's a fraction, I'll make the left side a fraction and ask, what does x get multiplied by? Well, that's 1 because that's this cross product right there. And 1 times x is x, and x would be equal to this other cross product, which is 13 times the cosine of 37 degrees. All right. Now, I would tell you that you could have said, okay, I'm going to use, instead of angle A over here, I'm going to use angle B. Okay, if I had done that, I would be looking for the opposite leg length, and I would know hypotenuse. Well, opposite and hypotenuse, that's the sine. So I could have said the sine of 53 degrees is equal to the opposite leg length x divided by the hypotenuse 13. Make a proportion out of it. That cross product, which is x, will equal that cross product, which is 13, times the sine of 53 degrees. Okay, and it would matter if you typed in 13 times the sine of 53 degrees, or whether you typed in 13 times the cosine of 37 degrees. You're going to get the same answer either way. Okay, all right, and that means, let's just write one of these down here. 13 times the sine of 53 degrees, and that is approximately 10.38. Is that 2 going to stay a 2, or is it going to go to a 3? Well, it looks like that number to the right is one of your 5 smallest digits, so it's going to stay a 2. Okay, all right, let's move on. Next, we have this part C. It wants us to write an equation, okay? All right, and I guess it wants an equation for x is what it should say. Well, if we're going to do x, the only acute angle I know is this one here. So I'm going to use that. Let's call it angle A, if you like, okay, or 51. It's the same thing as a 54-degree angle. And if I'm looking for x, all right, I don't want to use y because that's an unknown. I'm going to do the adjacent leg length divided by the hypotenuse. So I would say that the adjacent leg length and hypotenuse is cosine. So the cosine of 54 degrees, all right, is 8 divided by x. Now, this is a little different in the past because if I make a proportion out of it, x doesn't get multiplied by 1. That's okay. It doesn't really matter, okay? I'm going to write x. I'll come up here. Hold on. Let's hold off on that for a second. I would do x times the cosine of 54 degrees. That's still going to be a number, and that's going to be equal to the other cross product, 1 times 8, which is 8. And then I would need to do one more additional step to solve that for x. I would need to divide by the cosine of 54 degrees. Okay? So when it says x equals, you could put 8 divided by the cosine of 54 degrees. That would work for you. I'm going to go ahead and put that in. 8 divided by cosine of 54 degrees. Okay. All right. And that would give you approximately 13.610. All right. Now I'm going to find y, equation for y. I'm going to use the same known angle that I was given, acute angle 54. If I want to find y is opposite that 54 degrees, and I know the adjacent leg, not the hypotenuse, because I might have made a mistake finding that hypotenuse. I could use it, but I don't want to. I would do the tangent of 54 degrees is equal to the opposite leg length, y, divided by the adjacent leg length, x. Make a proportion out of it. What does y get multiplied by? That's 1. So y would be equal to the other cross product, which is 8 times the tangent of 54 degrees. All right, now hold on just a minute. All right, I've got that hypotenuse, x, sitting here. I'm going to store that in x for a minute, okay? All right, so I've got x. Now I'm going to find y. All right, y is 8 times the tangent of 54 degrees. All right. So y would be 11.011. All right, 11.011. By the way, if you want an equation, you could do 8 times the tangent of 54 degrees is equal to y if you like. That would work. All right, now I'm going to show you that if I were to do, I'm going to store this in y. Let me do that. So store alpha y is the 1. All right. I'm going to show you that if I were to do 8 squared, oops, I didn't square it, excuse me, 8 squared, plus y, which is alpha 1 squared, I get that number right there. That should be the same thing as x squared because I stored this quantity for x. Did I get the exact same thing? And the answer is yes, I did, all the way across the board. Okay. All right, let's go to D. All right. In part D, excuse me. Let's find x first because it wants an equation here for x. Well, here's the known acute angle 50 degrees. X is opposite. I know hypotenuse. Which trig function has opposite and hypotenuse? Well, that's the sine. That's the sine. Sine is defined as opposite divided by hypotenuse. So the sine of 50 degrees will be equal to x divided by 11. All right. Make a proportion out of it. Multiply x times 1, that's x equals, all right, 11 times the sine of 50 degrees. All right. So next we would approximate that. So 11 sine 50 gives you that decimal approximation. All right. Well, I'm going to put this sine of 50 degrees. This is the equation that you probably ought to start out with. And that means that x is approximately, where are we? 8.426. Okay. All right, let's go find y next. All right, I'm going to maintain that same acute angle, and I'm going to do the adjacent leg with the hypotenuse. That's cosine. So the cosine of 50 degrees, and that's the equation, the cosine of 50 degrees will be equal to the adjacent leg y divided by hypotenuse. So y divided by hypotenuse. If I make a proportion out of it, y gets multiplied by 1. That would be y equals 11 times the cosine of 50 degrees. All right, and 11 times the cosine, let me put that in, 11 times the cosine of 50 degrees would be 7.07, look to the right of that 0, 7.071, okay? So approximately 7.071. All right. Now, one other thing that you need to know, all right, let me make sure we're in the right place here, all right, is this, all right? You can use this calculator to find the measure of an angle of a right triangle, provided you know 2 more bits of information about that right triangle other than the right angle, okay? All right. Now, let's go back to the 3, 4, 5. That's one of those Pythagorean triples that I asked you to memorize. Let's say that triangle A, B, C is the 3, 4, 5 Pythagorean triple, all right? I'm going to show you how you can use your calculator to find the measure of angle A and B, because that's the only thing we don't know about this right triangle. Everything else we know. Well, that's called solving a triangle. When you get all three angles and all three side lengths, you have solved that triangle. So that's basically what we're getting ready to do. Okay, so we need to decide which angle we want to find. Let's just, for alpha purposes, find angle A first, all right? Well, I have options because I know all three side lengths. Well, I like sine, so I'm going to do the sine of angle A is equal to, well, sine is defined as the opposite 4 divided by the hypotenuse, 5. Now, anytime you're looking for an angle measure, and you might want to write this down, you must use what we call an inverse trigonometric function, all right? And that means that the measure of angle A will be equal to the inverse sine, and that looks like this right here, of the ratio 4/5, okay? All right, so let's do that. All right, now, to get the, so we are looking for the measure of angle A over here, all right? We will do the inverse sine. To get the inverse sine on your calculator, you press the blue button before you hit the sine. There's the inverse sine. Then you put in the ratio that is the sine, which was 4 divided by 5. And when you hit enter, it will come back and give you the angle measure. All right, so the measure of angle A is 53 point, let's do 3 decimal places, 130 degrees. All right, now, you could do one of two things to get angle B. You could subtract that from 90. That's what I'm going to do. I'm going to take 90 and minus 53.130, and there is B. I will tell you that immediately. Or you could say, okay, I'm going to come over here and find angle B using my trigonometry. All right, and you'll see that it works either way. All right, if I want to find B using trigonometry, I need to decide which trig function I want to use, whether I want to use the sine, the cosine, or the tangent. Well, let's just pick the tangent. So I could say that the tangent of angle B is equal to, tangent is defined as the opposite 3 divided by the adjacent 4. All right, and that means that the measure of angle B will be equal to the inverse, whatever we chose, which was the tangent, of this ratio 3/4. Okay, all right, now I've still got B sitting there, all right, by the way, and if I do the inverse tangent of 3 divided by 4, I should get the same thing, all right? And if I were to round that answer right there, and by the way, watch this. If I made that calculator round that answer, all right, if I pull that back up and hit again, it would round it basically to the same thing, all right? So the measure of angle B would be equal to 36.870, and those would indeed add up, if I'm not mistaken. If I took that 36.870 and added it to the 53.130, they better add up to 90 degrees if they don't, I've done something wrong. All right, if you have any questions, you can call me, email me, or show up in one of our Google Meets. Thank you. Have a good day. Bye.